Good morning. It's November 20th, and this is your daily brief in science. Here's everything you need to know. A recent study utilizing data from the Dark Energy Spectroscopic Instrument, or DES-1, has provided a detailed analysis of cosmic structure growth over the past 11 billion years. This research serves as a precise test of gravity on a grand scale, affirming that gravity operates according to Einstein's general relativity. These findings reinforce the current cosmological model and narrow the scope for alternative theories of modified gravity. The DES-1 project is a collaborative effort involving over 900 researchers from more than 70 institutions worldwide, managed by the Lawrence Berkeley National Laboratory. Currently in its fourth year of a 5-year survey, DES-1 aims to observe around 40 million galaxies and quasars. In April 2024, the project unveiled the largest three-dimensional map of the universe, suggesting that dark energy might be dynamic rather than static, a notion that aligns with the latest findings. This analysis sheds light on dark energy, believed to be responsible for the accelerating expansion of the universe, indicating that its strength may vary over time. Researchers are looking forward to updated measurements on dark energy and the universe's expansion history, expected in spring 2025. Previous findings leaned towards an evolving dark energy model, prompting interest in further exploration. Pauline Zaruk, a co-leader of the study, highlighted the significance of testing general relativity on cosmological scales beyond our solar system. Mark Mauss, a PhD student at UC Berkeley, expressed enthusiasm about how cosmic observations could address fundamental questions regarding the universe's composition. The study also established new upper limits on neutrino masses, indicating their total mass should be less than 0.071 electron volts per speed of light squared, refining earlier measurements. Analyzing nearly 6 million galaxies and quasars, this research provides the most accurate measurement of cosmic structure growth to date. The implications of these findings extend beyond gravity, influencing various areas of cosmology and enhancing our understanding of dark matter and dark energy, which together account for about 95% of the universe. Overall, while general relativity explains much of the universe, it does not fully account for dark energy, prompting ongoing exploration into its dynamic nature. A suspected case of avian flu in a child from Alameda County has raised concerns among health officials. The California Department of Public Health reports that the child exhibited mild upper respiratory symptoms and had no known contact with infected animals. This case is currently under investigation, with test specimens sent to the Centers for Disease Control and Prevention for confirmation. California Department of Public Health Director Dr. Thomas Aragon reassured the public, noting that the child is not believed to be infectious. He emphasized that there has been no documented human-to-human transmission of bird flu for over 15 years. Both the child and their close family members have received preventive medication, with all tested contacts returning negative results. Local health officials are actively monitoring caregivers and families who may have been in contact with the child, providing preventive treatment and testing. Despite 53 human infections reported in the U.S. since April 2024, the Centers for Disease Control and Prevention maintains that the risk to the general public remains low. This case marks the 28th confirmed human case of bird flu in California, notable as the first not linked to sick farm animals. Health officials confirmed the presence of the H5 virus subtype, typically associated with birds. Epidemiologist Jennifer Nuzzo pointed out that the virus's presence in wastewater complicates public health efforts and raises pandemic concerns. Additionally, the recent detection of H5N1 in pigs has prompted alarms about a potential new reservoir for the virus. In related news, a teenager in British Columbia is critically ill from H5N1 bird flu, with the source of infection also unidentified, raising further concerns about broader transmission. Scientists have made a significant breakthrough in stem cell research by successfully reprogramming mouse cells into pluripotent stem cells using a gene derived from schwannoflagellates, single-celled organisms that are closely related to animals. This study challenges previous beliefs about the genetic origins of stem cells, suggesting that important genes like SOX and POU may have evolved much earlier than once thought, which could have played a role in the emergence of multicellular life. Choanoflagellates possess versions of the SOX and POU genes, which are crucial for inducing pluripotency in mammalian stem cells. This indicates that these genes existed before the evolution of animals. Led by Dr. Alex de Mendoza from Queen Mary University of London, the research team, which included experts from the University of Hong Kong, demonstrated that choanoflagellate genes can create stem cells capable of contributing to life. The findings, published in Nature Communications, reveal the continuity of gene function over nearly 1 billion years of evolution, as highlighted by Dr. de Mendoza. These results have significant implications for both evolutionary biology and regenerative medicine, providing insights into how stem cell therapies and reprogramming techniques can be optimized. Dr. Ralph Jausch pointed out that investigating these ancient genetic tools could lead to innovations in enhancing pluripotency mechanisms, potentially utilizing synthetic versions of these genes for improved performance. When injected into a developing mouse embryo, the reprogrammed cells formed a chimeric mouse, demonstrating the roles of these ancient genes in development. The study suggests that early versions of SOX and POU proteins were used by unicellular ancestors for essential cellular functions, which were later adapted by multicellular organisms for more complex developmental processes. This research builds on the foundational work of Shinya Yamanaka, who in 2012 showed that differentiated cells could be reprogrammed into stem cells using specific factors, including SOX2 and OCT4. Overall, the research emphasizes the evolutionary potential of genetic tools, illustrating how ancient mechanisms could inform modern advances in cellular specialization and tissue repair. The Solar Orbiter, a joint mission by the European Space Agency and NASA, is reshaping our understanding of the Sun. Launched in 2020, it has been delivering unprecedented views of the Sun's surface, recently releasing high-resolution images that showcase detailed sunspots and moving plasma. These images reveal the Sun's photosphere, where temperatures range from 4,500 to 6,000 degrees Celsius. This area is characterized by a grainy texture, a result of convective movements within the Sun. In addition to the photosphere, the extreme ultraviolet imager has captured the Sun's corona, showing plasma at temperatures around 1 million degrees Celsius flowing along magnetic field lines. The polarimetric and helioseismic imager has provided the highest resolution views of the Sun's surface to date, mapping its magnetic field and surface movements. The PHI team is able to track plasma movement on the Sun's surface, observing that it generally moves with the Sun's rotation, diverging near sunspots. Understanding solar activity is essential, as it can disrupt power grids, GPS systems, aviation, and satellites, while also creating auroras around Earth's poles. Currently, the Sun is at solar maximum, the peak of its 11-year activity cycle, which is marked by increased solar flares and coronal mass ejections. Missions like Solar Orbiter and NASA's Parker Solar Probe are tackling fundamental questions about the Sun, including the origins of solar wind and the high temperature of the corona. The Parker Solar Probe is set for its closest approach to the Sun in late December 2024, enabling scientists to examine solar activity directly from within the solar atmosphere. Future observations from the Solar Orbiter will focus on imaging the Sun's poles, which remain poorly understood, enhancing our knowledge of both the Sun's corona and photosphere. The PHI team has also developed new image processing techniques for high-resolution mosaics, with plans to produce such detailed images twice a year moving forward. Researchers are tapping into the potential of earpiece microphones, known as hearables, to detect early signs of Alzheimer's disease by monitoring changes in eye movements, specifically saccades. Led by Rachel Buserhall from École de Technologie Supérieure and Chris Niemczak from Dartmouth College, this study aims to test this innovative method on 35 Alzheimer's patients. To further enhance the research, the study will also include 35 healthy controls, allowing for a comparative analysis of the technology's effectiveness. Alzheimer's disease currently affects over 50 million people worldwide, causing immense distress for patients and their families, with no cure available. In the United States, approximately 6.7 million individuals live with Alzheimer's, a number projected to rise to 13 million by the year 2050. This alarming trend underscores the urgent need for early detection tools. While there is no cure, early interventions can delay the onset of severe symptoms, making accessible diagnostic methods crucial. Early diagnosis remains a challenge due to the disease's gradual progression and the lack of clear indicators. The study of eye movements, particularly saccades, has shown promise in predicting dementia risk, although it is not yet widely implemented in clinical practice. Eye movements are closely linked to motor skills and cognitive function, making them a compelling target for early diagnosis, according to researcher Avian. Traditional eye tracking methods can be expensive and cumbersome, prompting researchers to explore hearables as a non-invasive alternative for long-term monitoring. The future aspirations for this technology include its application in monitoring other neurological diseases, enhancing the differentiation of symptoms through in-ear signals. Ultimately, the findings from this study are expected to contribute to the development of a wearable diagnostic tool for Alzheimer's disease. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.